Hi friends, let's see the 12th class concepts from electrostatics. Hope you know by this time whom I am. I am the physics retired lecturer from Kendriya Vidyalaya. Here you can see this is my YouTube ID. If you type this, you can reach to me and you can see my online classes which I am giving you especially for NEET preparation 2026. This is contact number. You can contact 11th and 12th physics lectures I am giving. Also some live classes I used to conduct from 9th to 12th physics. Let's start today's part 4 of electrostatics. That is concept is electric field. The remaining three, which I have already uploaded in YouTube, that is about introduction of electrostatics, how to create the charge, frictional electricity, and then properties of charges, Coulomb's law, and then some charge density. You know that Coulomb's law apply for only point charges. We cannot apply for the size is more. So for that we used to consider three types of charge densities: linear charge density, surface charge density, and then volume charge density, which will help you to find out how to find electrostatic force on the charge which is greater than point sizeless. Let's see now the second part in fourth of YouTube class. Here I am giving you electric field. See, like a gravitational field, electric field is also there, that is space around the charge. You know the charge by this time. We can create the charge and we can see that we can test the charges, properties, etc. All those things I help you already done it. So this like gravitational field, same way electric field you will be going to study. So gravitational field means it is the strength of the earth up to which it can pull the object. Same way the electric field is same the space around the charge in which the other charge felt electrostatic force. That is what electric field. Then to find the electric field due to a point charge, which is very, very important. Children, now point charge means very small charge, and one question going to come. It is given in NCERT book for all Indian students. You can study that. It is very simple. That problem also I will put on here in YouTube. Then next going to superposition principle. So electrical field due to the number of charges presence on the charge will be equal to vector sum. It will be a vector sum. Understood? Vector sum means direction to be considered. So that vector sum we are going to see in the superposition principle. Vector sum of all the electrical field, like even force also, same thing, right? So the force on a body or charged body is the vector sum of individual forces acting on the body. Right? Same way here also the superposition principle of electric field is the force or field at any point is the vector sum of individual field on that point. Right? That will be you are going to see. Then very important is for NEET and the 12th class, electric lines of force due to a point charge, due to a dipole, due to a equal and like charges, due to a uniform field. This is what actually the newly added of these four application part of electrical field you are going to see. That is what electric field line. What is line? It is imaginary line. Okay, it is imaginary line with which the touch charge is going to move in the electrical field, right? That is called electric lines of force. Due to point charge you are going to see, due to dipole you can going to see, due to equivalent like charges, right? Due to equal and like charges, right? Dipole means what it is? Two equal and opposite charges are placed at a short distance, which you are going to see in the chemistry. H2O, hydrogen and oxygen, is form a dipole, positive and negative charges, sodium chloride, it is a dipole. Like that, so many things are there in chemistry. For that is not my aim to explain here. My aim to explain is here is just a dipole. How do we see their electrical field lines? If it is positive and negative is kept apart a certain distance, then you can see that how the field lines will go from positive to negative. Same way electric dipole, that is magnetic dipole. I think it is you have seen even in ninth class, 10th class, magnetic field lines, uniform field, how it will be, all those things. The other concepts are there. The properties of electric lines of force, electric dipole, electric field intensity, torque is very, very important, right? When a dipole is placed, it experiences rotational force. That we call it as torque. Torque is nothing but some agent which is rotating the system. That is called is the talk. Work done. Yes, work done on the dipole when it is placed in the uniform electrical field. So that time you are going to see that certain derivations are there. It's not that difficulty. One should keep the concentration, then you can understand. Let's start the things one by one. Right? What is this electrical field? What is electrical field? You can see here, this is a big charge. That means charge is greater than the smallest charge. Smallest charge I told you now 1.6 into 10 to the power of minus 19 coulombs. If it is a bigger charge means combination of 4 5 charges or more the number of charges will become a source charge. So it is producing electrical field around this, right? You understood? This is the source charge, right? You can see here. What is this? This is a source charge. It is creating electrical field around it. The same manner, how gravitational field around the earth, the same way here also the some field will be there. That field will be called electrostatic field or electrical field simply, right? So I brought it a very small charge, that is touch charge. We call it as very small charge. I kept it close by, right? So here is two charges are there. One is positive charge, other one is negative charge. Positive charge is called source charge. Other Q0 is vanishingly small positive charge. Why do we need to take vanishingly smallest charge? Because this source charge should not get disturbed by this smallest charge. Otherwise, what will happen? If I take bigger one here, this will get repel and move away. So that should not happen. So very small charge, that we call it as vanishingly small charge placed at that particular point. So the finally we're going to see here, this is what is happening in this system. One is fixed, other one is freely placed. It is because of this electrostatic force, it will get repel and move away. See that? How large, how this, how the body. If you throw a ball, ball will come down. Why it is coming down is Newton, great scientist, who gave Newton's law of gravitational force. The same way here, When charge is kept nearby, it will repel and move away. See, this force is acting on this. How much force is acting on this by this charge gives you electric field. Hope you understood. Once again, I repeat, right? This is the source charge. I kept it here. One smallest charge. Because of this electrostatic field of the source one, it effect on this and it will start move in this direction. That is the force on that charge due to this source charge. We call it as F arrow. That is, F is a vector quantity. I think you understand here. Now let's see another diagram. Instead of positive charge, because I told you already, there is two fundamental charges. One is positive proton, another one is negative, it is electron. Electrons, so charge I have taken, right? It is a little bit more number of electron together as a point charge I am considering. Now I am taken again positively vanishes. In this case, both I am taking attached charge of positive only, because we have to define the content. We have to define the physical quantity. So by considering same charge only, positive charge only, we need to take here. So positive charge will be kept again in the presence of source of negative charge. Just expect what will happen. Everyone will say it will attract. Why, because they are equal and opposite charges. They are opposite charges. Sorry, it is not equal, it is opposite. So which one is moving? The smaller one is moving. You see this. This is the distance. Now smaller one. In earlier case, it will be going away. Here this is pulling inside, right? Then this is why it is pulling inside, because attraction force. Here, first one, repulsion force. It is going away. Why these two things happening? Because there is a strength of this source charge at this particular point, right? Because of that, it is moving away or pulling inside, pulling inside, right? That is called electric field. Hope you understood. Electric field means force on the point vanishingly charged, vanishingly small positive charge. At that particular point, in the presence of electrical field of the source, that is called electric field at that particular point. So now come to the definition is very simple. Electric field strength at a point in electric field is the electrostatic force per unit positive charge acting on vanishingly small test charge placed at that particular point. This is just English is troubling you. You simply listen that. It is a force on a vanishingly test charge kept at particular point in the presence of electrical. That's it. That's it. Okay? Same thing. So you write your own English number, but meaning should come. That's all. Whatever you are understanding here, that is fine. Right? Coming to your Q is source charge, Q not touch charge, F is force, electric field. See this? E is what? Electric field. Right? So in mathematics, you have seen that LT means limit. What limit you are consider here in the experiment is the source, the test charge, whatever you are taken, unit test charge should be very, very small. It tends to 0 F by delta Q. Then F by Q. Instead of right, generally we can write like this also. This is the mathematical expression. This is a simple way. You learn this. This is enough. Right? Then force you submit. What is that Coulomb force? Q1, Q2 by R square, all this nonsense you have to put here. Okay, Q1 is Q only, Q2 is Q0.